Every bulletproof vest begins with a spool of bright yellow fiber and a level of scrutiny most industries never require. At the receiving bay, aramid fiber arrives from certified suppliers, each batch tagged with strength ratings and full origin documentation. Nothing enters production without a verified paper trail. In the materials lab, technicians pull-test fiber samples to their breaking point, while electron microscopes examine every strand for consistency. Only fiber that passes this gate moves forward. Spinning machines twist raw fiber into strong, uniform yarn. That yarn feeds into industrial looms, weaving a dense, ballistic-grade fabric at high speed. Every square inch of woven fabric is inspected by eye and by digital scanner before it earns a certification stamp. Layers of that fabric pass through a resin bath, bonding under heat and pressure into rigid composite sheets. Meanwhile, ceramic powder boron carbide, silicon carbide, is pressed into flat blanks and fired in furnaces exceeding 2000 degrees Celsius, fusing into an extremely hard strike face plate. Once cooled, each ceramic plate is precision ground on diamond wheels, then tap-tested and ultrasonically scanned for hidden flaws. The ceramic plate is bonded to a fiber-reinforced backing inside an autoclave. Heat and pressure fusing two materials into one. Finally, every edge is sealed against moisture, and a protective coating locks the plate's surface against wear. This is only the beginning of what it takes to stop a bullet. A finished plate is only half the story. The soft armor that wraps around it demands its own precision. Dozens of fabric layers are stacked and cut into standardized panel shapes by computer-controlled blades. Every pattern optimized to waste as little fiber as possible. Workers layer each cut piece by hand. Following an exact sequence, the number of layers determines exactly how much protection that panel provides. Heavy-duty industrial machines stitch the stack into a single unit, following a quilted pattern that keeps every layer locked in place. The finished panel is sealed inside a waterproof film, protecting the fibers from moisture that could quietly weaken them over years of use. Meanwhile, durable carrier fabric is cut and sewn into the vest's outer shell pockets, straps, and webbing built to hold everything together. Buckles and quick-release hardware are riveted on and tested by hand, again and again, until every mechanism works exactly as it should. In final assembly, soft panels and plate pockets come together into one complete vest, checked against a strict list before it ever reaches a testing range. And then comes the real test. A panel is mounted on calibrated clay, a certified firearm fires a single round, and technicians measure the exact depth of the impact. Ceramic plates face their own reckoning, high-velocity rifle rounds, fired behind reinforced barriers, followed by ultrasonic scans checking for hidden cracks. Only what survives this stage earns the right to protect a human life. Passing a single test isn't enough. Every result must become part of a permanent record. Quality engineers compile every test result into a formal certification package, cross-checked against national ballistic standards before any design earns approval. In a separate line, sheets of ultra-strong polyethylene fiber are stacked in precise layers and pressed for hours under extreme heat, creating a rigid plate lighter than ceramic, but just as determined to stop a threat. Water jets trim each plate to its exact body contour shape, leaving clean edges without a trace of heat damage. A protective coating is sprayed on, and a laser permanently etches a lot number and certification code directly into the surface, a plate's own fingerprint. In the fitting lab, mannequins of every body size test carrier coverage, making sure vital organs stay protected no matter who wears it. Completed vests are pushed through accelerated aging chambers, extreme heat, humidity, and years of simulated wear compressed into days. Only then does a vest reach final inspection, where every stitch, every buckle, every panel placement is checked against an unforgiving list. A permanent serial number links that exact vest to its full manufacturing history forever. It's packaged, sealed, and moved into a secure warehouse, waiting for the moment it will actually matter. Behind every vest issued to an officer is a chain of decisions most people never see. Agency representatives review certification data and sizing options long before a single unit is ordered. Protection here is never a guess. Each officer is individually measured, ensuring full torso coverage without restricting a single movement. At graduation, quartermasters hand over each vest, verifying serial numbers against official issuance records before explaining proper care. Years later, that same vest returns for scheduled inspection, checked for wear, tested for function, and retired the moment it falls outside its certified service life. Meanwhile, in the research lab, engineers test entirely new fiber materials, chasing lighter weight and stronger protection for the next generation. Hand-built prototypes, documented variable by variable, move toward comparative testing long before mass production is even considered. Computer simulations model bullet impact across dozens of configurations, revealing weaknesses long before a single physical plate is made. Every international shipment passes through strict export compliance, verifying end users and licensing requirements before a single case leaves the building. And when a vest finally reaches the end of its service life, it's destroyed under controlled procedure, its materials responsibly recycled, its story properly closed. Every vest eventually becomes part of someone's daily readiness and part of a much larger mission. Technicians configure pouches, radio holders, and webbing onto the carrier, building a complete duty loadout suited to one department's exact needs. At live demonstrations, buyers examine cutaway samples firsthand, seeing the ceramic, the backing, the soft layers exactly as they exist inside a real vest. Government auditors walk an elevated gallery above the production floor, watching every stage of manufacturing at once as part of a full facility certification. For long-time customers, technicians evaluate whether an older carrier can be upgraded with newer, lighter plate technology protection that improves without starting over. New production workers train for hours on slowed-down machines before ever being certified to work independently on a live line. Supervisors and engineers meet regularly, reviewing defect data and refining specific stages of production based on what the numbers actually show. Fabric, scrap, and cutting waste are sorted and redirected into recycling programs, reducing what the facility sends to landfill each year. Real-world field reports from agencies feed directly back into future design decisions, protection that keeps learning from what officers actually experience. In the lobby, certification badges and company milestones remind every visitor of the mission behind the machinery. And at dusk, the entire secure campus glows under industrial lighting, fiber halls, weaving floors, testing ranges, and warehouses, all working toward one single purpose. Because at the end of this entire journey stands one officer, on one ordinary patrol, wearing something that was never meant to be noticed, only trusted.